Okay, let's start. So, good evening, everyone. I hope you can hear me. Can anybody confirm that? You can see my screen and I'm audible.
Yes, sir.
Okay,
You are audible.
thanks. Thanks. So, good evening. My name is Sandeep Yadav. I'm a Prime Minister's Research Fellow at Department of Energy Science Engineering, IT Bombay. I'm a teaching assistant in this course, and I'm taking a weekly live problem solving sessions on this course called NPTEL HS24, named as Energy, Resources, Economics, and Environment. This is the ninth week of this course, that problem solving session. In this week, we will cover the input output analysis of that part of that course. So before moving ahead, I just want to make sure that previous week's assignment is solved. So I will just go through this before starting the lecture. So this is the previous week's assignment. If you have any of the queries related to this, you can ask me in between. I will explain all the questions. So question number one says, company is planning to take a loan for an energy project. Which of the following does the loan repayment does not depends on? So as we have seen, we have already solved this type of questions already. The loan repayment does not depends on the discount rate. So that would be the right answer. Second question says, a solar power plant of a 15 megawatt capacity has a capital cost of 45 crores. Calculate the annualized capital cost in crores for the 25 years so the here the life cycle is given as 25 years and discount rate is given as 30%. So now we have to calculate the annualized capital cost. So annualization factor we have to calculate, that is we can also call it as a CRF. So CRF is D 1 plus d to the power n. So n is 25 years and 1 plus d to the power n minus 1. So when we solve this equation, we will get the d is equal to annualization factor as 0.3004. So for calculating the annualized capital cost, we just need to multiply the annualization factor to the initial capital cost. So that is 45 into 0.3004. That comes out to be 13.52 crores. So that will be the answer for that. I hope this is clear to everyone. If not, you can ask. Now moving ahead, the Bachat Lamp Yojana by Bureau of Energy Efficiency, that is BEE, included replacement of incandescent lamps by LED bulbs, CFL bulbs, or solar powered lighting system. So initially they have started with the CFL lamps, but now they have moved to the LED lamps, as I've also explained this in the class. Question number 4. A PV power plant in Rajasthan has a capacity of 1000 megawatt. The capital investment is 3,000 crores, assuming a capacity factor of 18%, with a power purchase agreement guaranteeing a price of INR 3.5 rupees per kilowatt hour, assuming a lifetime of 25 years. Neglecting O&M costs, answer the following. So first we have to calculate the internal rate of return. So for the IRR, we know first we have to calculate the annual cash flow. So annual cash flow we can calculate by. So we know there's a 1000 megawatt plant, and it's a megawatt to convert into the kilowatt. We have to first convert into the megawatt to kilowatt. That is multiplied by 1000. So that's why this 1000 came, and we have to multiply by the working hour. So in an year, a working hour is 365 by 24. That comes out to be 8760 hours. Now there's a capacity factor that is given. Only 18% of the whole year that capacity is available. So we have to multiply by 0.18 and 3.5. That is the uh, power per unit electricity cost. So now we will get this kilowatt hour, and if we are multiplying uh, INR into INR per kilowatt hour, this is the unit. The final thing that remains with us is in the units crores only. So that comes out to be 551.88 crores. I hope this is clear. Now for the internal rate of return, we have to assume first one value we are considering as a 0.2. So as IRR k plus 1 is equal to initial investment, annual cash flow divided by C naught, that is capital investment, and 1 minus 1 upon 1 plus IRR to the power 25. So when we solve this equation of after the first iteration, when we put the IRR is equal to 0.20, then it comes out to be 18.2, and after few more iteration we will comes out to be 18.10 percentage. So that's how we calculate the IRR from the iterations. I hope this is clear. Okay. Now moving ahead, which of the following is not an example of financing instrument? Multilateral development banks, soft loans, market-based loans, or grants. So we have already solved this type of question. That's multi-development banks is not in financial instruments. It's a For more details, you can just visit to this timestamp of this solution. Moving ahead to the question number 6, this says which investors has the highest expectation of the returns? The development banks, large corporations, mutual fund, or the venture capitalists. So here we have seen the venture capitalists expect higher returns as compared to the all other three options. Now, question number 7 is true and false. The cost of capital in case of corporate finance is relatively higher than that of project finance. Is it a true or false? It's a false statement, because cost of capital in the case of corporate finance is relatively lower. Otherwise, that project will not be feasible. Now, question number 8. I hope the initial first 7 questions are clear. If not, you can just comment down in the comment section also, or you can unmute yourself and ask. Now moving to the final question, question number 8. A waste heat recovery project has an initial investment of 18 lakhs. If the constant annual cash flows are 10 lakh, the project life is 10 years. Calculate the net present value of the project. Assume that the discount rate is 0.3. So here first we have to calculate the annualization factor, that's CRF. So CRF is clear, d1 plus d to the power n, 1 plus d to the power n minus 1. So that comes out to be 0.3234. And for calculate the NPV, NPV is equal to initial capital investment, that is so that's minus comes because we are paying initially, that's why minus 18 lakhs plus that's a annual cash flow, that is 10 divided by CRF. So that comes out to be 12.92 lakhs. I hope all the questions are clear. If you have any doubt, you can just please let me know. Otherwise, we'll move ahead.
Sir,
Yes.
hello, sir. In question number, probably that CFL, the correct answer is CFL, but at that time, presently it is or depend on replacement of LED, na sir?
Yes. Yeah. Presently,
So
it's LED, but the Yojana started with the CFL lamps initially.
that's why that's why it is. That is CFL. Oh, okay, okay.
Yes.
Sir, one more question. It is not from this assignment. It is assignment number 2, question number 10, where there's a question that due to the Fukushima disaster, there is an increase in nuclear power generation in Japan. Sir, it is not right at all, sir. But in that case, it is the confusing is there. Question is not, the answer is not. It's too confusing, sir. Can you, sir, clarify that question?
For that, I think you can raise the queries in the that forum itself, because it's a quiz that's already gone. So if I'll explain this here, I have to go through that solution again.
Because there is because I have lost 1 mark, but it's not. I want to clarify that it is a true or false. The Fukushima nuclear power plant disaster led to an increase in the use of nuclear power. Japan. It is true or false? Sir,
Yeah, I got your question.
after the disaster of Fukushima plant, there is a decrease in certain decrease in nuclear generation in Japan, and after more
Yes,
than
yes.
1 decade after that, it is that again they are considering about to increase the generation of nuclear power in Japan. So how it is true, sir? That's why I can't understand which
So
cases it is
first,
true.
so I think you're talking about the question number
10.
10. Uh, True or false? A Fukushima nuclear power plant disaster led to an increase in the use of nuclear power plant. It just led to
How it is, sir? I'm not understand
So have you
how.
gone through the time snap of this time snap? You can just go through this again. Otherwise, you can raise a query on the forum. One of the TA will solve your query. If the question is wrongly interpreted, then you will be assigned the marks that you have lost.
Okay, sir. Okay, okay, okay.
Okay.
Okay, thank you, sir. Thank you.
Okay. Okay. So I assume that all the queries related to the quiz number 8 is now solved. Now we'll move to this week's content. So this week's content initially, so I'll just briefly go through the slides. So this week's content is majorly only a single topic, that is an input-output analysis. So input-output analysis is a type of energy model. So there are many models like model for energy market forecast or model for energy economic interaction. So in which input-output analysis is a type of energy model through which we can do a certain type of analysis. So the energy model classification has been done for a short on medium or long term basis, and there are some top down or versus bottom up approaches, simulation versus optimizations, and geographical coverage, global, regional, national, or the state, or even local levels. So this concept is given by a professor, Wesley V. Leontief. He has given that concept in around 1951. So he has explained the input output economics concerning a new method which can portray both an entire economy and its finite structure by plotting the production of each industry against its consumption from every other. So this type of analysis, this is a relation between a one industry to an inter industry energy transfer. So that has been shown by these tables. So if you go, so these tips, these are the theory parts already explained in the video. So I will just go through, skip these sections. Now I'll move ahead for the basic input output analysis. So here input all the values are in the monetary units. Here xi is equal to total output of the sector I, and Zij is the input from sector I to sector J, and Fi is the final demand of the sector I. So all the values on the monetary. So if you write Xi is equal to Zi1 plus Zi2 until Zin plus Fi, then finally we can write into the equations X1 is equal to Z11 and similarly Xi to Xn in the similar manner. When we will write into the input output matrix, x is equal to x1 to xn, z is equal to z11 to z1n and zn1 to znn, and f is equal to f1, f2, f3 and until fn. So this is how we will write input output matrix. These things will be more clear to you when we will solve the questions. Now output is related to input used through a fixed coefficient as a linear relation, and this is an input output equation. I is here I is an identity matrix. I minus a into x is equal to f. So when we will be asked to calculate the f, we know the a, we just need to calculate multiply this I minus a into x, then we can get the value of f. So we will solve few questions about this, and then you will get the clarity about the input output analysis. So I have a few questions. This is the balance equations. And there are some definitions that L is equal to labor services, N is equal to all other values added, M is the imports, C is the consumptions, I is the investment goods, G is the government, and E is the exports. So these are the values that we are going to use frequently. So we'll just remember that what the acronyms represents. So there's an example that's solved by sir. If the final demand for the agricultural output were increased from $600 to next year, for manufacturers were to decrease to $1,500. So F new is equal to F1 new, or F2 new is equal to 600 to 1,500. Now this computing the output, L is equal to 1 minus I minus 8 inverse. So for this actually we just need to know the basic mathematics, how to calculate the determinant, how to calculate the inverse of a matrix. So knowledge of matrix as matrix level mathematics is expected from all of you. So this is how that question was solved. So I'll not go through this again. So again, this I think we will move ahead. There's a one thing that I explained, the inter-industry. Inter-industry means from one industry to another industry, energy transfers or the monetary demand transfers or demand imports and exports. So here F is the matrix of total final demands, X is the matrix of total final outputs. So that's how we can calculate the inter-industry energy flows also. So there's a tutorial that has been solved in the, I think, lecture number 43. So you can go through this again if you want this. We will solve other type of questions because this type of questions are already covered. So that's all for this week. This week's content is majorly about the theories and the numericals. So we will solve the numericals that will give you more insights about these topics. If you have any doubts, you can clear. Otherwise, we'll move ahead. Fine. Okay, then we'll move ahead to the this week's content. So we'll start with the short type of questions. This is basically a theory type of question. Then we'll move ahead with the numerical answer types and the tutorial questions. So question number 1 says, which of the following models is not as suitable for long-term energy forecasting? If you want to try this question, you can just comment down your answers, or you can unmute and just tell that what do you think the right answer would be. So first question is, which of the following models is not suitable for the long-term energy forecasting? First is uh, econometric model, optimization model, input-output model, or the end-use accounting model. So the answer would in the for this question would be the input-output model, because input model output model is not for, sorry, it is not for forecasting, first of all, and all other models are used for forecasting. That's the econometric optimization or end user accounting model. So the right answer will be input output model. This is not suitable for long term energy forecasting. Second question says, which among the following is not an assumptions of input output model? First is technical coefficients are constant, economics of scales are ignored, each industry considered is in this analysis has to transact with every other industries. So in that case, as we know, in the input output analysis model, the assumption that first assumption that we have taken is model considers a short term relationship between different sectors of economy. Thus, the coefficients which relates the industry with each other, technical coefficients, are assumed to be constant. So option number one will be correct. And assumed to be similarly, economics of scales are ignored. So the option number second will also be correct. So it is not necessary that each industry in the matrix transact with every other. For example, if we'll take automobile industry may not have a relation with crude oil sector. We are talking about the direct relationship here. So that option number C will be the correct. So this will not be an assumption of the input output analysis. I hope these two questions are clear. Then we'll move ahead. So question number three. Question number three says, let me check the comment box if there's any query. Question number three is about true and false. So input output analysis is a short term analysis model. This statement is true or false. Anybody wants to try this question? Want to answer?
It is true.
It's true. Correct. It's true is the right answer. Why? Because we have already explained in the question number two that input output analysis considers a short term relationship. Input output analysis considers short term relationship between different sectors of economies. So that's why that statement is true. Now question number four, consider a coefficient matrix A for an n sector economy. What does a coefficient A12 indicate here? So while writing the coefficient matrix, rows indicates the selling sectors and the column indicates the so here rows when we write a coefficient matrix. Write a coefficient matrix, then here rows indicates the selling sectors, means these rows indicate the selling sectors and columns indicates the purchasing sector. So thus in this question A12 indicates the units of sector 1 purchased by sector 2 for each unit produces by the sector 2. So units of sector 1 purchased by sector 2 so option number 1 will be the right option. I hope this is clear. Now moving ahead to the question number 5. So question number 5 says increase in energy efficiency of industry shall change the technical coefficients. Is it true or false? We've just given the explanations. So it is asking increase in the energy efficiencies of industry shall change the technical coefficients. Is it true or false?
Yes, it is input the output. It is true, sir.
It's not true. Can you explain why you're thinking so? So initially I've explained in that question number 2 itself, technical coefficients are constant,
Acha.
right? So what happens? A technical coefficient denotes, first of all, technical coefficient denotes the contribution of one sector to some other sector. Contribution to one sector to other sector. A contribution, so the contribution cannot be more than one. Either it can be more than 100% or it cannot be more than one. So that's why most of the cases that technical coefficient cannot be greater than one. So initially it was constant. So that statement is false. Now moving to the question number 6. For a Leontief inverse L for an n sector economy, value of L11 is 1.13. Select the correct statement. So I just given a wrong explanation for this question. This was the question related to that technical coefficient can be may or may not be greater than one. So in that case, I just confused between the two questions. Increase in energy efficiency of industry shall change the technical coefficient. So the statement is true. Why so? If the energy efficiency increases, the transactions between the industry shall change. Hence, the technical coefficient shall also change. So as we have seen, it depends the contribution as we have seen. This shows the contribution of one sector to another sector, of one sector to another, and when contribution increases, then technical coefficients shall change. So it will change from 0 to 1 only. So as we already know, it should be technical coefficients shall also be lies in the from the range 0 to 1. In that range, it can vary as per the energy efficiency increases between the different industries. So I hope now it's clear. Now moving to the question number 6. For an Leontief inverse L of an n sector economy, value of L11 is 1.13. Now we have to select the correct statement. The statement 1 says for an increase in output of sector 1 by 1 unit, final demand of sector 1 is increased by 13%. Option B says for an increase in final demand of sector 1 by 1 unit, output of sector 1 increases by 13%. Statement C says for an increase in final demand by 2 units, output of sector 1 increases by 2.13 units, or Option D says for an increase in final demand by 2 units, output of sector 1 increases by 2.26 units. So first we'll solve a diagonal matrix in Leontief inverse matrix is always greater than 1, and it indicates the percentage change in the production of sector per unit change in the final demand of the sector itself. So there's a value 1.13 here. If you see 1.13 indicates the that is for the supplying 1 unit from the sector 1 from 1 unit. So here 1.13 indicates supplying 1 unit of sector 1. A total output of sector 1 should increase by 13%. Then by this logic, if the demand of sector 1 is 1, is sector 1 increases to 2 units. Now if the demand of sector 1 was 1 unit and increased to 2 units, then output should increase by 2 into 1.13. That will be equal to 2.26. So that's why correct answer will be for an increase in demand, final demand by 2 units, output of sector 1 increases by the 2.26 units. I hope this is clear now. If you have any doubt, you can ask. Sector. Okay, moving ahead. Which of the following models looks into energy economics interaction? First is energy demand model, second is optimization model, third is simulation model, or input output model. Anybody wants to try this question? That's a very basic one. For the models that looks into the energy economic interaction is input output model. So the option number D will be correct. Now moving to the question number 8, it says input output model is a top down model. It's true or false? It's already explained in the class. You must be able to answer. It's a direct yes or no question. So input output model is bottom to up model. So that's why that statement is false. Question number 9. The input output model acknowledges the and incorporates the economics of scale. Is this true or false? You have just explained this type of explanation for this. Anybody wants to give an answer for this question? I'm repeating again. The input output model acknowledges and incorporates economies of scale. Is it true or false? It's very easy. You must be able to answer this.
True, sir.
Yes, someone is trying to say.
It is
Yes.
true, sir.
Is it true?
Yes, true, sir.
Okay, so okay, then we I just gave an explanation of if you go to the question number 2, what we have considered, which among is the following is not an assumption of input output model. So that if you are taking in assumptions that economics of scales are ignored, that means in this analysis, economies of scale are ignored in the input output model. So that statement must be false. Correct? Oh, it's good that you're trying at least. That you'll understand where the things are going wrong. So now moving to the question number 10, which of the following assumptions are not true for the input output model? The economies can be divided into inter industry sector and final demand sector. The production operates under constant return of sales. Technical coefficients are constant. Yes, this statement is true. Each industry considered in this analysis has to transact with every other industry. So we have just also seen this statement must be wrong because it's not necessary to for each industry to interact with every other industries. So we can consider the economies can be divided into the inter industry sector and the final demand sector. This is also true. The production operates under the constant return to scale. This statement is also true. Only one statement that it's not required, not necessary. Okay. Now moving to the question number 11. Consider coefficient matrix A for an n sector economy. What does the coefficient A12 indicate? A unit of sector 1 purchased by sector 2 for each units produced by sector 2. A unit of sector 2 purchased by a sector 1 for each unit produced by sector 1. A unit of 1 purchased by sector 2 per unit of production of sector 1, or a unit of sector 2 purchased by sector 1 per unit production of total output of all sectors. So that's a straightforward answer. That is A12. This is A21. This is also something that when we solve this detailed question, then you will find this type of questions are very basic. Now we are moving to the question number 12. A pulp industry supplies 4 millions worth input to a paper products, includes whose annual production is worth 60 millions. What is the technical coefficient of the transactions? So now we'll calculate the technical coefficients. So first we should know that here Zij is equal to 4 millions as it's given here. As we know, the technical coefficients and output of the annual production, or we can say the output is given as xj. Here it is 60 millions. So the technical coefficients
for 4 by
would
60.
be, yes, xj, that is equal to 4 by 60. So when we calculate this, 4 by 60 would be equal to 0.066. That will be 0.066.
0.66. 0.66.
Yes, sorry, 0.66. Sorry, it's a 0.66. Sorry, this is 0.066. 0.066. So the answer would be A, 0.06. So we have to just given the answer up to 2 digits. So that would be the answer. I hope it is clear.
Point 26.
Okay. I think someone is unmuted. Can just please unmute yourself, and when you watch. Okay, thanks. Okay. Now moving to the question number 13. For a Leontief inverse L of in sector N. So this type of question we have already solved. That question would answer would be 2.26, as you indicate that if the 1.13 will be the 1 then in the final output with the 2 units, it would be 1 into 1.13 into 2, that is 2.26. Now moving to the question number 40. A product of sector used internally, that is an electricity which is used within the electricity sector itself, is called a subsidiary consumption, auxiliary consumption, supplementary consumption, or substitute.
It is auxiliary,
Yes.
sir. It is auxiliary.
Yeah, it's auxiliary consumption. Correct.
Auxiliary.
Yes. So usually when we talk about the power plants, there is some amount of electricity that is internally consumed. Example, I'm just giving an example. Some amount of electricity is consumed by the power plant itself. That's called auxiliary consumption. That's typically ranges from 2 to 3% of that overall power. Now moving ahead. So that's all about the short type of questions. If you have any of the doubts, you can just let me know. Otherwise, we'll move ahead to the numerical answer type questions.
Sir, can you give me the previous slide, sir? Previous slide.
Yes.
Before this.
Okay.
Yes, sir. Sir, it is, there is XZ is equal to 60 million. Okay, sir.
Yes. Yes.
Or ZIZ is equal to 4 million. So AIZ is equal to 0.066.
Correct.
Okay, sir. That is a technical coefficient.
Yes.
Yes. Okay. Thank you, sir. Thank you.
So if you are confused between this, I'll just explain you briefly what's technical coefficients. So as you seen in the slides also, if you go to, yes, these are the matrices that we have explained. And here if we will go to the technical coefficient. Yeah, technical coefficients, as we can see the sector 1 to sector 2, from the agriculture to the manufacturing. We consider agriculture sector 1 to sector 1, that's 0.15, and we have to calculate the technical coefficients. Technical coefficients are calculated, if you've seen these questions. So that's available in this type. The solution of this questions that explained in the details. When we go through the, I think lecture number 43, when this whole question is explained, you will go through the how the technical coefficients is calculated. That's xi upon xj upon zij upon xj.
Where ZI is the input from sector I to sector Z. That is the industry transaction.
Yes.
Yes. Okay, sir. Okay.
Okay, now moving to the content. So now we'll start the numerical answer type questions. So first question says, consider a technical coefficient of the matrix is given as A 0.35, 0.25, 0.3 and X. Now find what value of X Leontief inverse does not exist. So we'll solve this question. So first we know Leontief matrix L. So L is equal as I minus A inverse, where I is the identity matrix. Identity matrix is 1, 0, 0, 1. That's 2 cross 2 matrix I'm drawing here. So we can write it I minus A is equal to 1 0 0 1 minus A, here it is given 0 0.35, 0 0.25, 0 0.3 and x. So when we do that calculation here, I minus A, so I minus A would be equal to 1 minus 0 0.35 is 0 0.65 and 0 minus 0.25 is minus 0 0.25 here. 0 minus 0.3 is minus 0 0.3 and x minus 1 minus x here, and we will do this calculation. So friend, now L matrix of 1 minus A matrix, for any matrix to exist, determinant of the matrix has to be non-zero. So for now we'll calculate the determinant. Conversely, the determinant of any matrix is zero, then inverse does not exist. So we know these two statements. Statement one says, one is for any matrix to exist, determinant has to be non-zero. And statement two is determinant of any matrix is zero. That means inverse does not exist. So in that case, I minus A should be 0.65 into. So now we are calculating the determinant. Minus 0.25 into minus 0.3. It should be 0 for for the value of x. It should be 0, then only the inverse of that matrix should does not exist. So that's what in the asked in the question. So we're considering it as a 0. Now after solving this equation, we'll find 1 minus x is equal to 0.25 into 0.3 to divide 0.65. So that comes out to be 1 minus x is equal to 0. What is comes out to be 0.25 into 0.3 divided by 0.65. That comes out to be 0.115. Now for calculating the x, it is equal to 1 minus 0.115. So that means x would be 0.885. So if you round off, that would be x is equal to 0.88. So that's how we can calculate the value of x that's been asked in this questions. So it's asked for the two decimal places. So that's why we can convert to the 0.88. I hope this is clear. If not, you can ask.
Sir, can you show the statement two statement once again? Yes.
Statement 2 says here, it says determinant of any matrix is 0, then the inverse does not exist. So that's the statement that we have considered. It's been asked that for what value of x the Leontief inverse does not exist. So for any value of to consider that inverse does not exist, we need to consider the matrix have a determinant is equal to 0. So here we have calculated the determinant. This is the determinant of I minus a matrix. We have considered it as a 0. So when we consider it as a 0 and we calculate this, solve this equation, it comes out to be 1 minus x into 0.25 into 0. This statement minus cancel out and minus. So 0. If we divide this thing with 0.65, then it comes out to be x is equal to 0.88. Is it clear?
Yes, sir.
Okay. So similar way, we'll solve this question. Consider a two-sector economy. For a unit of final output of sector A, it requires 0.2 units from itself and 0.5 units from sector B. For a unit of final output of sector B, it requires 0.15 units from itself and 0.9 units from sector A. Now, the thing that we have to calculate is a Leontief inverse for given economy will be given by, and the second thing is if the final demand for the sector A and B are 10 units and 15 units respectively, then the total output of sector 1 and sector 2 will be, we have to calculate. So let's solve. So first we will form a matrix that is given. So it says it requires 0.2 units from itself. That means if you will write in the matrix form, it will be 0.2 and 0.05 from the B. So it will be written as here 0.05 from the B. And it says again, sector B is requires 0.15 units from itself. That means BB 0.15 here and 0.019 units from. So if you write A, B, A, B. Now from A to A is 0.2, A to B is sorry, B to A is 0.9, B to A is 0.05 and B to B is 0.15. So now if we will write in the form of Leontief matrix Leontief inverse, that is I minus A, and it comes out to be 1.12, 0.04, 0.01 and 1.13. So how we have calculated? It's first we have just divided this A matrix from identity matrix, and then we have calculated the inverse of that whole matrix. So I'm not solving this basic mathematics here. You can just, if you have any doubt, you can just go through this mathematical solution. It's a 2 cross 2 matrix, so it would be easy to calculate the inverse of that matrix. So now moving ahead, it would be equal to 1.26 into 0.07, 0.13 into 1.18. So, sorry, just return it. So if you will calculate the inverse of that matrix, let me just solve it here so it will not create any confusion for you. So for here we have just written A is equal to 0.2 and 0.09, 0.05 and 0.15. I will just quickly solve I minus A. minus A will be equal to 1 minus 0, 1. Its identity matrix minus A 0 0.2, 0 0.09, 0 0.5, 0.5. When we solve it, it comes out to be 0 0.8. It's minus 0 0.09. It comes out to be 0 0.05 and 0 0.85. Now it's I minus A, and when we will calculate the inverse of that. Now calculating inverse is easy, and when we calculate the inverse, it will be comes out to be 1.26, 0 0.13, 0 0.07, and 1.18. So after that, you have to find that inverse of that matrix, and then you will finally get the negative inverse. That comes out to be this thing.
So all the technical coefficient in the diagonal should be 1, greater than 1, no, sir?
No, it can't be greater than 1. It will be always be from the 0 to 1 only. Technical coefficients. It's the basic property of that.
No, the diagonals always be greater than the diagonals. The diagonals, it is
Yeah,
1.2,
yes,
1.18. There must, they
yes,
always be greater than 1.
yes.
Hmm.
So now we'll move ahead to the question number 2 of this same question. This we have solved. Question number 2 says if the final demand of sector A and B are 10 units and 15 units respectively, and then the total output of sector 1 at A and B should be. So now total output is equal to X is equal to L into F. We have L is equal to 1.26, 0 0.13, 0 0.07, and 1.18. That's the thing that we have just calculated. That's a Leontief matrix. F is given here. Final output is for the sector A is 10, sector B is 15. Now X we can calculate L into F. So when we calculate L into sorry L into F, that comes out to be X would be equal to 1.26, 0 0.13, 0.07, 1.18 multiplied by 10 into 15. So when we multiply that thing, we will get, when we solve this, we'll get around 14.55 and 18.40. So that means the final output of sector A would be 14.55 units, because there's no units is given, and B is 18.40. We have solved the second part of that question also. If you have any doubt, you can ask. Any doubts? Okay, I consider this question as solved. Now I'll move ahead to the question number 3. So that's a similar type of questions. If you can see, anybody wants to give it a try, you can just try it. I will give you 2 minutes to solve this question. Then I will, if you are not able to solve it, I'll just solve it for you. It's a similar type of question that I've solved. If you want for the reference, you can just take this question as a reference. We consider this question as a application of question number 2 that we have solved. It says 20 tons of steel is need to be produced, out of which 2 tons of steel is required and 1.5 tons of coal is required. So here instead of A and B, steel and coal is written, and to provide 30 tons of coal, 5 tons of steel and 3 tons of coal is required. So it's an inter industry relation that has been shown here. So anybody wants to try this question, or you're trying? I should wait, or I should solve this straight away. Okay, so let's see. If we'll see here, first thing is given is steel, second thing is coal. Same here, steel and coal. So uh, for the demand of 20 tons of steel and 2 tons of steel is required, and 5 tons of and 1.5 tons of coal is required. And similarly, 30 tons of uh, demand of coal, 5 tons of steel, and 3 tons of coal is required. So that's how we calculate the matrix. So final demand is given here is 20 tons of steel and 30 tons of coals. So total output would be 20 plus 5 plus 2 is equal to 27. And here 30 plus 3, 33, and 1.5, that is 34.5. So that's how we calculate the total output. Now, if you will write this thing into the matrix form, it would be 2 by 27, 1.5 by 27. Because for calculation, as we have solved in the video, if you've seen the video uh, lectures by the sir of this week, then you will find then for creating a matrix, a technology matrix, we have to divide amount of this tail divided by the total output. Total output. So in this way, we can 2 by 27 by 5 by 27, 5 by 34.5, and here 3 by 34.5. In that way, the A would comes out to be, you can just quickly solve this. It would be 0 0.074, 0 0.145, 0 0.055, and 0 0.087. So this type of question you can expect in your final exams also. So as you already know, the final exams of this or HS24 course would be on the 27th of April. This is the exam of 27th of April. That's an announcement that I'm making here. It's already been. You will also receive a mail from NPTEL team. So currently it's on this date.
So did
You
you
just note it down.
so did you Sir,
Yes.
it is 27th April, it is Saturday.
Yeah, it's on the Saturday.
It is not probably that normally the NPTEL exam will conducted in Sunday, but it is in Saturday.
No, on the Saturday, Sunday, both the days are there.
Okay, okay.
Yeah. So the hall tickets will be available, or it should be available now itself. You can choose your center of examination and all. You can just prepare this type of questions. So now moving ahead to the second part of this question, if the demand of steel is increases to 25 tons and the goal of decreases to 28 tons. Now for the output of the input of the steel would be. Now let's solve this part also. So now we have to calculate X, that is L into F. L we have, L should be I minus A inverse into F. I minus A would be 1 minus 0, 0, 1. A we have just calculated 0.074 and 145, 0.055, 0.087. When we solve it, it comes out to be 0.926 minus 0.145, 0.055, 0.913. And when we solve, this is I minus A. And when we calculate I minus A inverse, it would be when you solve this, it would come out to be 0.109, 0.173, 0.066, 1.106. Thus, finally, when we calculate the X would be this thing. Sorry, X would be 1.090, 0.1. I'm just repeating this thing again. 173, 0.066, 1.106 multiplied by, question says it would be increased by 25. Sorry, 25 and 28 tons itself. So we'll write it similarly, 25 and 28 tons. Then X, when we solve this multiplication, it comes out to be 32.1 and 32.6. So steel would be the final outputs would be for the steel, it would be 32.1 tons, and for the coal, it would be 32.6. I hope this is clear. If you have any doubt, you can ask. Okay, if you don't have any doubt, we'll just move ahead to the question number. In just numbering is, I think it's problem. Here 1, 2. This was question number 1. This was 2. This was 3. Now this would be question number 4. Is it clear? Question number 3. Question number 5, 4 is very basic. A limestone industry supply 50 lakhs worth of input to a cement factory whose annual production is rupees 15 crores. Calculate the technical coefficient. We have just solved this type of question in the recently.
Sir, one question is that.
Yes.
Sir?
Yes.
Sir, in previous question.
Okay.
In previous question, if we take in coal as a first row and steel in second row, is it that answer will be the same?
No,
Here,
answer would be different. Because the matrix that we will make in a such a way, like if you're taking steel and steel in the first row and the first column and the coal in the second row and the second column. So in that way, we can relate what is the theory part is saying. If you will say steel, if you can read the statement, to provide a demand of 20 tons of steel. So we know the demand, it is 20 tons here. This is 20 tons. For 20 tons, 2 tons of steel is required here. 2 tons of steel is required from to make a steel. So this is the relation between steel to steel. And 1.5 tons of coal is required. So it is 1.5 tons of coal is required. Similarly, for if you see that other part, a demand of 30 tons of coals, 30 tons of coals, 5 tons of steel is required. This is the relation between steel to coal. And for the coal to coal relation, that is A22, that would be equal to 3 tons. So that's how these things are calculated. Means written in the form of table.
that is A1 to A 1 1 1 2 2 1 2 2.
Correct. If you
Yes,
write it in that form, that would be A11. This is A12. This is A21, and this is A22.
yes. Okay. Sir, one second, sir, one second,
Yes, yes.
Yes, yes. Okay, okay,
Okay. Okay. I hope it is clear now.
yes.
Okay. Now let's move to the question number 4. It says a limestone industry supplies 50 lakhs for worth rupees input. So we know now ZIJ. ZIJ is 50 lakhs and output is equal to let's output output of cement industry is 1.5 crores. So if we write 1.5 crores, it would be 15 into sorry, 0 and 0. So that would be equal to xj. Now we know technical coefficients is
Z I Z
z
I Z
upon
by
upon
X
xj.
Z.
So what would be 15 lakhs, 15, 50 lakhs, sorry, 50, 50, and 5 more zeros. Divide by 1, 5, 3, 4, 5, 6, 7, 8. That would be equal to 0.033.
Yes.
So technical coefficient would be 0.033. So that's the basic questions that we have just I just wanted to get a touch of that again. So just put that question. Now we will if you're not having any doubt, we'll move ahead to the tutorial type of questions that would longer type of questions that will contains whatever the knowledge that we have got till now. We'll use that type of concepts and try to solve a bigger question. So first we will move to the question number 1. Number 1 says so it says use the following table to answer the question. So we have this table in which sector 1, sector 2 and payments and total outputs. All the values are given in the monetary units. Their final outputs and the total outputs are already given. So the table is already given to us. The first question is asked: the unit purchased from sector 2 for each unit of sector 1 is, that is from the for the units purchased from the sector 2 for the parts unit sector 1 is equal to. So we have to solve it. That's asking from Z to 1. That's asking A to 1. A to 1. A to 1 would be, so we know Z to 1 is 2, Z to 1 is, that's 1 1 1 2 2 1 and 2 2. Z to 1 is 150 and X1 was given 1000 total output. So as we have just solved in the previous question itself, now we have to technical coefficients of A to 1 will be Z to 1 divided by X1. That would be 150 divided by 1000 and it would come out to be 0.15. So the answer for the question number 1 would be 0.15. That means a unit purchased from sector 2 for the sector for each output of the sector 1 is equal to 0.15.
So it is sir, it is the value of the direct coefficient from sector to sector 1.
Correct.
Yes. Yes.
So now the you're getting the physical significance of the whatever the technical coefficient says it all. How to solve this? Means get the insights of that. Okay, so this was the part A. Now moving to the part B. It says Leontief matrix of this input output table. IO means input output table is given by. So now we have to calculate the Leontief matrix. So A. So first we have to calculate the A. First we have to calculate the matrix A. So A would be, so as you have seen sector 1, it's 200 divided by 1000, 400 divided by 4. So it would be equal to 200 by 1000, 150 by 1000, 400 by 1500 and 50 by 1500. So that's how we calculate the matrix A. So when we calculate the A, we can calculate the A would be 0.2, 0.27, 0.15 and it would be 0.03. Now Leontief matrix would be I minus A inverse. So I minus, first we will calculate the I minus A, and I minus A would be 0.8 minus 0.27 minus 0.15 and 0.97. And when we calculate the inverse of that, then it would become 1.32, 0.36, 0.20 and 1.09. So that's how we can calculate the Leontief of this matrix. That's called. Yes.
So there is a step between these. We have to find the determinants, na sir. In between that.
Correct. You have to first find the determinant. You have to divide the determinant and calculate the inverse. That's a basic mathematics that I don't want to solve in each question. That's why I'm just putting it directly. If you want to solve it, 0.8 into 0.97 minus 0.27 into 0.15. Yes, and 0.8 divided by. Yes, if you will going to solve this whole thing, determinant and calculate the inverse, you will get the same value. If you want to try, I can just stop and you can try it in between. Now we have solved the two parts of this question. Moving to the part 3. So part 3 says, if the final demand were to change to 500 units in sector 1 and the 1000 units in the sector 2, calculate the new output values. It's a similar question that we have solved recently. So that's all x new. X new we have to calculate. It would be equal to L minus F new. L we have just calculated. That's 1.3 to 0.36, 0.20 and 1.09 into what's asked. It's a 500 and 1000 units respectively. If you can solve this matrix, you will get 1020 and 1190. This is X new. So the answer would be like in a what would be calculate the new output. Output will be new. Output would be 1020 and 1090. I hope this question is also clear to you. If not, you can just wait. You can ask your doubts if any. So now we'll solve this question. You can just read it. I'll give you 2 minutes and as I'll come back, then we'll continue. So I hope you read the question. So it says according to the postulate of Leontief, the exchange of goods shipped from the ith sector of economy to the j sector is proportional to the activity level xj. So xij is equal to aij minus xj. Also, the activity level of ith sector is reckoned as a sum of all the outputs xii consumed within the that sector. That's xij is equal to j is equal to 1 and all these things. So now imagine a closed economy of 3 sectors which is characterized
Sir,
by the
one
following.
question,
Yes,
sir. I want to
yes.
interrupt you. Just I want to ask a question, sir. Whether we can use that scientific calculator in exam
No,
because
no physical
it is,
calculators would be allowed.
it is already there, na sir, in
Yeah,
uh,
if you have given the GATE exam or any other for online exams, the online calculators on the screen is already available. So the questions
acha,
would be of that level that could be solved from that calculator
cal-
itself.
okay, okay, sir. Okay, thank you, sir. Okay.
Okay, so we'll continue. So now we have to construct the complete input output table, including a row for the value added to each sector by factor services, and confirm that the various accounting identities has been observed in the construction table. Now we have to calculate the matrix A, that is Aij of input output coefficient. Use the method cost elimination or the back substitution, solve that I minus A is x minus is equal to y and factors. So we'll solve with start with the initial uh, table first. First, we will make a table. So this is a three sector. So sector 1, sector 2, sector 3. And this is the final and this is final and total demand. Sorry. Sector 1, this is sector 2, this is sector 3, this is factors, and this is for activity level. So when we write, this is S1 sector 1, this is sector 2, this is sector 3, this is S1, this is S2, this is S3, this is final demand, this is total demand. These are the factors, and this is the activity level. So when we see the matrix that is given, that is 10, 30, 10, 30, 50, 20, 10, 20, 20. Similar thing we will write here 10, 30, 10, 30, 50, 20, 10, 20, and 20. And the other thing is given 50, 100, and 50. So that's equal to 50 for the sector 1, 100 for the sector 2, and 50 for the sector 3. If you calculate the total demand, 50 plus 10 plus 30 plus 10, that would be equal to 100. Similarly here 100 plus 50 plus 20 plus 30 is equal to 200, and here 50 plus 20 plus 20 plus 10 is equal to 100. So that's how we calculate the total demand. Now factors are given y1, y2, y3. Here factors are given as 50, 100, and 50. If we calculate the final demand of the factors itself, it would be equal to 200. Now activity level is the sum of all these uh, sector 1 from the factors, that's equal to 100, and for the sector 2 is 200, and for this is 100. So now we have formulated the trade flow activity levels for the final demands are in this input output table. So first thing we have calculated is input output table. This is how input output table is made. Now the matrix A of the input output table and the Leontief coefficient I minus A would be. When we calculate the I minus A, the A would be, so till now we have solved only over 2 cross 2 matrix. This is the first time that we are solving 2 cross or 3 cross 3 matrix. So for the matrix A would be equal to 10 by 100, uh, 30 by 100, or 10 by 100. So this thing would be 0 0.1, 0 0.3, 0 0.1, and similar way this thing would be the sector B. So these things are coming from if you want to A11 would be 10 upon 100, that's 0 0.1, and this is 30. If you see here, this is 10 upon 100, this is coming from here, 30 by 100, 0.3 here, and 10 by 100 again 0 0.1. And similarly for the other sector 2, 30 by 200, that's 0 0.15, this is 2.5, 0 0.1, and similar fashion we have calculated all other these things. I hope this is clear. And identity matrix we already know, I is equal to 1 1 1 0 0 0 0 0 0. Now I minus A, if you will calculate, that would be 0 0.9 minus 0 0.15 minus 0 0.1 minus 0 0.3, 0 0.75 minus 0 0.2 minus 0 0.1 minus 0 0.1, and 0 0.8. So imagine that vector of final demand becomes y is equal to y1, y1, y2, y3 dash. That's equal to 60, 120, and one. That's then first thing we have to calculate. Then we have to correspondingly activity levels is. So let's assume y equal to y1, y2, y3 dash. That's equal to 60, 120, and 60. So in the question itself, it's written, we have to assume that. That's why we're assuming. Now, to find the corresponding activity level, x is equal to x1, x2, x3 dash. We must solve I minus a into x is equal to y. So now we have I minus a, we have just calculated 0.9 minus 0.15, 0.1. You're just writing it the same thing again. This is I minus a. I just copy it here, just paste it. It. So, and other thing is, we'll write x1, x2, x3 is equal to 60, 120, and 60. So we are writing it 60, 120 because it's given in the question, if you can see it. Now, if we solve this equation, we will get the values of x1, x2, and x3. So let's solve it.
Sir, please go to the previous slide once again.
Yes. Are you done?
Okay, sir.
So now the further question says we have to use the Gauss elimination method and the back substitution to solve this equation I minus xy. So we know in the Gauss elimination and the substitution method, first we will solve this equation by adding the first row to the second row and to the third gives. First thing we will add first row to the second row. So first row would be same. Now we are solving the matrix. First row would be same 0.9 minus 0.15 minus 0.1. Similarly, x1, x2, x3.
So this is third order matrix, no, sir?
Yes. So what we are doing here, we are multiplying 3 to the second row, row 2 multiplied by factor of 3. Then we see 0. Minus 0.3 becomes minus 0.9. 0.75 becomes 2.25, and minus 0.6 minus 0.2 becomes minus 0.6. And similarly in this was 60, this was 120. So if you multiply by 3, it becomes 360. So other substitution we are making here is we are multiplying and row 3 to multiply by 9. So we are doing this to solve this matrix. This minus 0.1 will be 0.9. This is also 0.9. This is 7.2, and this is 60. 60 into 9 will be 540. Now we're adding first row to second row and second row to third row. This will give us 0.9. First row will be remain same. This will be x1, x2, x3. This would be 16. So first row this would be 0.0. This will also be 0.0 because we are adding first row to second row and first row to third row. This was first row. First row. When we add, this would be 0. This would be 2.1. Minus 0.7. This would be minus 1.05. This would be 7.1. Similarly, this would be 420. This would be 1200. Now solving it further, adding the second row of final expression to third row gives us, so let's do it, 0.9. First row would be similar, 0.15, 0.1. This would be x1, x2, x3. This would be equal to 60. Second row would also be same, 0.0, 2.1 minus 0.7. Now we are adding the second row to the final expression and the third row, that would be equal to 0, 2 point minus 2.1, and that would be 14.2, and sorry, was 0 and 13.5. So now what is the thing that we made here? Can anyone of you guess? We have made a lower triangular matrix here. If you can see, we have made a lower triangular matrix. Solution of a lower triangular matrix would be equal to its so if you will find the solutions, so in that case x1 would be 120, x2 would be 240, and x3 would be 120. Is it clear? Yes. So when we solve this, we will get these equations, the values. So finally, the question was asking activity levels three sectors. Calculate the matrix A is equal to A by J that we have calculated. And the activity levels from the sector and the final demands are given. So that's we have calculated here. If you have any doubt, you just clear it. Otherwise, if we have time, we can just solve few more questions if time permits. Otherwise, you can try these questions from yourself, and if you're not able to solve it, just solve this in the next few classes.
Sir, one question is there.
Yes, you can ask.
Sir, what will be the pattern of final exam?
Okay. So have you attended the live sessions that has been conducted on the last week, Saturday?
Uh, I go through in after that, not in live session.
Okay, there has
But
been a live session that is conducted on, I think, what's the date
I
of
read that
Saturday?
that 30 number questions for 2 marks, and for 8
Yes,
number questions it is 5 marks.
yes. There's a session conducted on the 23rd of March by Professor Banerjee itself.
Mm.
I was also present in that session. So in that session, if you will see, there's a live recording is available. I will share the link for you if not shared by the NPTEL team. In that, whatever the type of pattern of that question paper is shared with you along with some new concept that has been done. Pattern of the paper, how the papers will be conducted, and the questions will be objective type only, and there will be some numerical answer type. The pattern will be objective and numerical answer type. It's also called NFT type. So the number of questions and the number of objective type and the numerical answer type will vary according to the demand or the question paper itself.
Sir, what is net?
That is numerical answer type. If you can just solve it, this the same thing. Do you have any other doubt? All clear. So if you don't have any further doubts, we should move ahead. The question number 3. Question number 3 says a farmer sells potatoes and tomatoes in the market. During the day, he customers. First customer demands 2 kgs of potatoes and 1 kg of tomatoes. The second customer demands 1 kg of potatoes and 2 kgs of tomatoes. The third customer demands 5 kgs of potatoes and 2 kgs of tomatoes. The price of potatoes per kg is 30 rupees and price of potatoes are 20 rupees per kg. Now we have to draw a input output table for the given. So now we will draw the same table. I'll just copy it. So we have to draw input output table first. So now we will replace all these things. Just before doing it, just draw it again. First, we are drawing your input output table. The first column is a customer, second would be the input 1, third will be the input 2, and third would be the output. This would be equal to customer. This is input 1, this is input 2, this is output. So input 1 is potatoes, input 2 is tomatoes. This is one customer number 1, customer number 2, customer number 3. And we can write here is a total. So customer number 1 wants 1 kg, 2 kgs of potatoes. This is in kgs. This is also in kgs. This is the price of potatoes is 20 rupees and price of tomatoes are 20 rupees. This is 30. So if you complete this table, this is 1, 2, 5, and total is 8. Here total is 5. And if we will total here, that's 30 into 2 plus 20 into 1 is 80. Similarly here 190 and the total is 340 rupees. So now from this table, we have calculated the input output table. The part 1 IU table. First thing we have input output table and the revenues earned by the farmers from the each customer. So revenue from the customer 1 is 80, revenue from the customer 2 is 70, customer 3 is 90, and overall revenue. Overall revenue is 340 rupees. I hope till now it's clear. Now question number 2 they are asking is formulate a mathematical expression to show a relationship between the price of potatoes and tomatoes and quantity sold and the revenues. So let be let y be the revenue, x1 be the quantity demanded of potatoes and x2 be the quantity demanded by tomatoes, and also px will be the price of potatoes and py with the price of tomatoes. Then we can formulate a mathematical expression for the same thing. Mathematical expression would be px into x1 plus py into x2 would be y. So to calculate the total demand, this is also satisfy. For example, if you will calculate that for the customer 1 here, customer 1 input potatoes will be 2 kgs and inputs will be 1 kg. So revenue must be 80. In that case, we should be able to solve this 30 into 2 plus 20 into 1, it should be equal to 80. Similar, 60 plus 20 is equal to 80. 80 would be equal to 80. So now that's verified that mathematical expression is correct. Now moving to the third part. Third part, they're asking if the fourth customer visits the shop and demands 3 kgs of potatoes and 2 kgs of tomatoes, calculate the revenue earned by the farmer. The mathematical equation to formulate by the question number B. Now let's move to the question number C. Using the mathematical expression, the total revenue of 3 kg of potatoes and 2 kg of tomatoes will be. So from the px plus x1 plus py plus x2 should be y. So 30 into 3, yes, it's given, plus 20 into 2, it would be 130 rupees. Now, therefore, revenue would be 130 rupees. So I hope it's clear now. The question, all the 3 questions that we have solved. If you have any other doubts in these questions, please let me know. Is consider is I hope it's clear to all of you. So there are a few more questions that we can sort, take it as homework, or you can solve it if you want. So more explanations. I will add that into the PPT and the content that we shared.
Both are
So today's
next
session
slide.
is
Hello.
yes. Yes.
So this one. Okay, sir.
Okay.
Sir, this type of question is very much time consuming. If it will be very
Yeah.
carefully, you have to. It is very much time
Yes.
consuming.
So you will not going to be solved this type of question in the final exams. Don't worry. Only a part of it you may be asked. Suppose that, there's a table you will be given, and you will be asked the what would be the 4 options will be there. So what should be the equations? So there will be 4 equations like this would be there. You have to find the only the right one.
To some extent, it is some formula is related to the statistics also. It is even
Yes.
from
Yes.
we can
So that topic input
graph.
output analysis is a yes. Yeah. Please go ahead.
From this type of equations on derivatives, we can draw the graph also. What is the demand
Correct.
for that particular day, or that for that particular farmers?
Yes.
He can calculate, if he can wisely calculate that, he can easily understand what will be his next demand in for next day or for few days or day to come, as per the
Yes.
market availability. What will be the price he can fix for his maximum profit.
Yes, definitely. So if you apply this question in the daily life also, you can just provide. So this the whole subject is related to the energy environment and the policies. So these are very related to day-to-day life. If you try to relate it in your regular life and solve these questions, you will definitely find the ways to capitalize the knowledge that you're gaining from this subject.
Yes.
And this part of this course is basically a environmental economics, or you can just this is a mathematical economics that we are doing, input output analysis. And the next part, next week we are covering the net energy analysis. So in that we will calculate how to the overall energy of the systems, or life cycle analysis of a part of a life cycle analysis we will calculate. So I think 3 more classes will be left. then the course will be complete.
Okay, sir.
So if you have any doubt, you can just please let me know. Otherwise, we'll consider this class is done for this week.
Okay. Thank you, sir.
Okay, thank you.
Sir?
Yes.
Sir, I have a question like the admit card which will be given to us, that it will be available in the mail itself, right?
Can you please repeat, your voice is breaking?
So actually, I'm asking that the admit card which will be given to us during for the examination purpose, but that admit card
Yes.
will be in the mail itself, available in the mail itself, or we have to search in the admit.
No. You have to you will receive a mail that on that link the admit card will be available, and when you click on that link and you will log in with your ID and password that you are going to use in the NPTEL login, then you will find a download admit card button. It will be there.
It will be available in
So
the
there is
portal itself, right?
the mail. We have still received not this type of mail till now.
You will receive in few days.
Okay.
Okay, sir.
Any other doubt, Atik?
No, sir.
No.
Okay.
Thank you.
Okay, then.
Have a good.
Thank you
Good
for
night,
the
sir.
attention.
Thank you, sir.
Good night. Good night. Okay.